Hey, what's good, Logan? Coming at you with another video. This one here is for Liliana. She was asking, how do you solve an equation by graphing? It's actually pretty easy, but if you miss class, I get why you would ask the question. The first thing you need to do is you need to understand that what we're doing is we're looking at the related function. That means we need to have a y. You'll notice that in these equations, there is no y. So what we want to do is we want to rewrite these functions, or these equations, sorry, so that they are in functional form. That means we want to have a y on one side. My suggestion is set the equation equal to 0 somehow, either the right side or the left side. Since this has the least on that side, I'm going to set the 12x equal to 0 by subtracting 12x on both sides. We're just going to take away the 12x on both sides of the equation. Now I can take away the 12x anywhere I want on the left side, so I'm going to choose to take it away from the middle. This gives us 2x squared minus 12x plus 18 is equal to 0. Next, change the 0 into y or f of x. So we're going to look at the related function. We'll talk a little bit more about why we do it this way, and then I'll go into a little bit more detail. So I'm just going to write it as y equals 2x squared minus 12x plus 18. Now, if you want to graph it by hand, you're more than welcome to do so, but my suggestion is you swap this thing over into Desmos. So we're just going to remember y equals 2x squared minus 12x plus 18, and we hop on over to Desmos and we type that in. Y is equal to 2 x to the power of 2 minus 12x plus 18. All right, now I'm just going to make sure that I did do that one correctly. So we'll go back over here, 2x squared minus 12x plus 18. Looks solid. All right, so what we're looking for on this graph is where does the y equal 0? And the reason we're looking for where y is equal to 0 is because when we look at the original function, we changed the y, or the 0, into y. So the idea is that we're trying to solve it when this guy is 0, because that would be this equation. So we look at the graph and we ask ourselves, well, where does y equal 0? So I'm looking at the graph. Y right now equals 2996. Y right now equals 1693. Y right now equals, oh, there it is. Y right there equals 0, also known as the x-intercept. So our answer is going to be the x-intercepts for this specific problem. So we're going to say that the answer is x equals 3. So we go back over here and we write that out. X is equal to 3. And as simple as that, we are done. Now, this right here is not the equation we're trying to solve because it has a y in it. That equation, that function, is what we're going to use to help us understand what the solution to the equation above it is. So we have the equation that we're solving for, 2x squared minus 12x plus 18 equals 0. And then we have the function that we're trying to figure out that's based off of it. Sorry, not trying to figure out. We're trying to graph based upon the original. All right, now let's ask another question. What if it wasn't equal to 0, but what if that number right there, right? So what if it wasn't 0, but instead it was equal to, I don't know, let's say 2? We would then need to figure out when it equals 2. Now, there's two ways to do this. You could subtract the 2 from both sides of the equation, and then you could regraph this with 2x squared minus 12x plus 18, take away 2, 16. Or, and this is to help us understand a little bit better, or what we could do is we could use the idea that instead of having 0, instead of looking for when the y is 0, what if we were to look for when the y was equal to 2? So we could say, hey, let's take a look at by the way, this is a secondary question. So the answer to the first question is just x equals 3. Now, if this right here was not a 0, let's say it's a 2, what I would do is I go back to the graph and I would look for when y is equal to 2. So I have to go up. It's going to be right about, oh, there it is. So y is equal to 2 at 4, but it has a second solution. The second solution is right there when x is equal to 2. So we have two solutions when y is 2. When x is 2, y is 2. Also, when x is 4, y is also 2. So we have two solutions for that other equation if we were solving that. So if it was equal to 2, what we could do is we could just find where the graph is equal to 2 using the original function right there. However, it was not originally equal to 2. It was originally equal to 0. So we're going to say that that's our solution. All right, let's get back to the topic at hand. What we're trying to do is we're trying to solve these equations using the graphing technique. What you really want to do is just set it to 0 and then find where it crosses the x-axis. If you want to get fancy, like I said in the last problem, you can. All right, this problem here, we're going to take away 1/2 x squared from both sides of the equation. That way we can get it equal to 0. So we have 0 equals negative 1/2 x squared that's a 2 right there, sorry, plus 6x minus 20. And we're going to graph the related function y is equal to negative 1/2 x squared plus 6x minus 20. And we're going to find when the graph hits 0 for the y value. So negative 1/2 x squared plus 6x minus 20. All right, so we'll shut that guy off and we'll type out our equation. Y is equal, oh, try that again, y is equal to negative 1/2, I need division, 1/2 x, oh, not there, 1/2 x to the power of 2 plus 6x, and I forgot the rest of the equation, so you know what? Let's go back and double check. Plus 6x minus 20, so plus 6x, take away 20, and then we're going to solve, 20, we're going to solve this graph here for when it crosses the x-axis. Huh, interesting. Negative 1/2 x squared plus 6x minus 20, it doesn't really cross the x-axis, right? So if I'm looking at these points right here, I can't find a single point where it crosses the x-axis. I'm trying. No, it never equals it because it has a maximum value at 2. So it doesn't, negative 2, it never actually gets to 0. So what that tells us is that this has no real solutions. So there are no real solutions to this equation right here because the associated graph, never crosses the x-axis. And that's how we graph problems. And this is how we solve equations using their graphs. We have to set it to 0, or it's ideal to set it to 0, and then you just look for the x-intercepts. All right, if you guys have any questions, please don't hesitate to ask. Luliana, thank you for asking that. It's going to help out so many people. I'll see you guys in class tomorrow.